Hello guys, today we are discussing one of the again interesting problem called trapping rainwater. Okay, let's see what's the problem is. Here आपको heights का एरे दे रखा है, ठीक है. आपको बताना है और ये जो हर एक इंडेक्स पे आपको वॉल दे रखी है कितनी कितनी यूनिट की वॉल है. नाउ यू हैव टू फिगर इट आउट हाउ मच वाटर यू कैन ट्रैप बिटवीन दीज वॉल्स. ओके, लेट्स सी. At zeroth index, there is no wall. At index 1, a wall of 1 unit. And then at index 0, there is no wall. So, and at index 3, there is a wall of 2 units. So, we can store 1 unit of water here. Again, 1 unit of water here. 2 unit of water here. 1 unit here. And 1 unit here. So, the total will be 1 plus 1, 2, 4, 5, 6. 6 unit of water we can store here. Let's see the next problem. Next input. Here you have given similarly an array of wall which is height of the wall is 4 unit, then 2 unit, then 0, then 3, then 2, and then 5. Okay, now you have to figure it out how much water you can store it here. So if you will see, right, after this, if I will store anything, right, it will get spilled out. So I can store 2 unit of water here. Okay, 4 minus 0, 4 unit of water here. Okay, 1 unit of water here, and 2 unit of water here. Okay, so 2 plus 4 6 plus 1 7 and 2 9. So 9 unit of water we can store here. Now see how we will approach this problem. Okay, so if basically if you have given, right, a wall. Okay, this is one wall, let's say of height 3 unit, and you have another wall at height, let's say 5 unit. Okay, now we have to figure it out how much water we can store it here, right? So what we will do, so this is at index 0 1 0 1 and 2. So one interesting observation here you can see is that at index 0 you will not be able to store any unit of water because it will get spilled out. Same apply at the last index also. If you will try to store any unit of water here, it will get spilled out. So we will always start from I equals to 1 to I equals to n minus 1, because लास्ट इंडेक्स पे बाउंड्रीज पे कोई भी यूनिट ऑफ वाटर स्टोर नहीं होगा. ठीक है, नाउ एट ईच इंडेक्स नाउ वी हैव टू फिगर इट आउट कि हाउ मच वाटर आई कैन स्टोर हियर. ओके, सो अगर उसका आप लॉजिक देखो तो हमारे को क्या करना पड़ेगा. we if I will get to know what is the left height of the wall at the left hand side and what is the height of the right hand side. Okay, and then whichever is the minimum I will take that. Let's say लेफ्ट हैंड साइड पे जो हाइट ऑफ द वॉल है 3 यूनिट है. ठीक है, राइट हैंड साइड पे जो वॉल है वो 5 यूनिट है. तो अगर मैं इन दोनों का मिनिमम ले लूँ तो मुझे पता चल जाएगा यहाँ पे कितना वाटर वी कैन स्टोर. सो मिनिमम ऑफ 3,5 विल बी 3. सो वी कैन स्टोर 3 यूनिट ऑफ वाटर हेयर. ठीक है, सिमिलरली अगर आप इसमें एज्यूम करो सेम एग्जांपल में, अगर आपके पास 3 यूनिट ऑफ वॉल ये है. ओके, एंड आपके पास 5 यूनिट ऑफ वॉल ये है. Now you have to figure it out how much water you can store, and at index 1 you have 1 unit of wall also. Now 3, you have given an array of 3 comma 1 comma 5. At index 0 there is a wall of 3 unit, at index 1 there is a wall of 1 unit, and at index 2 there is a wall of 5 unit. So how much water we can store here is, we can store only this much amount of water. And how much it is? It is 2 unit. Okay, how we will, how we have figured it out is, we will take the minimum of the maximum of left max comma right max, okay, and the minimum of these two index. So minimum of, so what I'm saying is, at each index how much water I can trap, how will we figure it out is minimum of left right, minimum of left max, okay, minimum of left max comma right max minus height of the wall, minus height of the wall. So if you will see this example, right, here the height of the wall is 1 unit, okay, and minimum of 3 comma 5 is 3 minus height of the wall is 1, because you have to subtract the height of the wall, right, because in at that place you cannot store water. So 3 minus 1 is 2, so you can store 2 unit of water here, okay. Okay, now I will suggest you guys, please pause this video and try to think a solution where you can solve this problem using naive approach. Okay, what will be our approach to solve this problem? Okay, okay. Now let's see how we can solve this problem. So again, you have given an array of height 4, 2, then 0, then 3, then 2, and then 5. Okay, this is what they have given you in the input. Now we are saying we will start at index I till n minus 1, okay, and each index, if I will get to know what is the left max and what is the right max, so how I will get to know? At each index I will run a loop to calculate a left max, and I will one more loop to calculate what is the right max after this index. And now when I will come at this index, again I will check, I will run a loop to calculate what is the left index and what is the right index, and then I will able to figure it out. I will sum up, and I will return the total water it can trap. So what I'm saying is what I'm saying is we will run one for loop int I equals to 0, say I greater than n minus 1, okay, I plus plus. Here what I will do, at each index I will calculate for int I have started with a 1. At each index I will calculate from the left side what is the left max, okay. So int k equals to 0, say k less than I and k plus plus. So from here I will be able to figure it out what is the left max, okay. And similarly for right max, again I will run one loop that will start from I plus 1 till n minus 1, okay, and k plus plus, and here I will able to figure it out what is the right max, okay. We will check a loop, if it is current index is less than the new index, we will update this right max, similarly the left max. But if we will and we will sum up and then return the total trapped water, okay. But if you will see this, right, this solution, it will take order of n square, okay, order of n square, because we are running one loop for traversing each element in an array, and then we are going left, we are going right. So one basically like inner loop, so it will be order of n square. Now let's see how we can optimize this solution. Okay, I will suggest guys, pause this video and try to think a solution where you can solve this problem with order of n time complexity. Okay. Okay, now let's see how we can solve it. So what I'm saying is we will start at index 1, and each index, if I will already pre-compute at each index what will be the left max, what will be the right max, right? So I don't need to run another loop to figure it out what is the left max and what is the right max. So what I will do is, the second solution is, solution second is, I will run one for loop to calculate a left max of each index. So what I will do, I will take an array of left max. Okay. Similarly, I will take one array for right max. Okay. Now I will run one for loop to calculate left max and one for loop to calculate right max. Let's see how. I greater than n, I plus plus. Okay. If array of, so I will consider this is an array of 0. Okay, and this I will consider array of n minus 1. Okay, now I will start with index 1. If any array of index is greater than left max, uh, like we will take two variable int left max, left l max, int r max. Okay, so we will initialize this as an left max as array of 0 and array of right max as array of n minus 1. Okay, this is an array. Okay, and we will initialize this variable, and if we will see any element which is greater than left max, okay, so what we will do, we will update the left max. Simple solution hai? We will update that left max. Same thing we will do for calculation of the right max. Okay, so same thing I will do to for the calculation of the right max. I will run one more loop from n minus 1, say n less than equals to 0, and I greater than equals to 0. Okay, and I minus minus, and I will check if it is greater than right max, then I will update the right max. Okay, so I will update the right max and I will store this right max and left max is an array. Okay, left max में डाल देंगे l max. Okay, and similarly right max में डाल देंगे r max. So once this iteration will be got finished, right, what we have is, we have take, what we are saying is we will take one left array, we will take one right array. Okay, and we will calculate. So we will start at this index. What is the left max for this index? Nothing, 4. What is the left max? 4. What is the left max for this index? 4. 4. 4. What is the left max for this index? 4. Or basically we will consider that also, so you can consider this is a 5. Okay, now we will start from the right index. So the right most index is 5. Now which is the like what is the right max of this index, which is again 5, 5, 5, 5, and 5. Okay, now what we will do is we will run for loop, one for loop to calculate this thing. Okay, so at each index, what I will do is I will take minimum of left comma right. Okay, minimum of left comma right. So 4 comma 5, minimum of 4 comma 5 is 4, and minus height of the wall. So 4 minus 4 is 0. So at this index I will store 0 unit of. Then it will come to index 1. Minimum of 4 comma 5 is 4, minus height of the wall is 2. So 4 minus 2 is 2. Again it will come to this index, minimum is 4, and I will subtract the height of the wall, which is 0. So 4. And then at this index, minimum is 4, and then height of the wall is 3. So 1 unit. Minimum 4 comma 5 is 4, and height of the wall is 2. So 2 unit. And again this, there is no water will be stored. How? Because the minimum will be 4. 4 minus height of the wall will be minimum, will be negative. So we will ignore the negative element. Okay. So if we will calculate this, right? Calculate this. So 2 plus 4 is 6, plus 7 plus 2 9. So which is your output. So this is the solution that we are proposing now. Is the time complexity of this solution is order of n, but it has introduced one more complexity called is space complexity of order of n, because you are using two additional array, left index and the right index. Okay guys, now pause this video, guys, pause this video, and can we improve it furthermore? Can we improve it furthermore? So at each index, right, at what I need to do is at each index, i I need to calculate what is the left max, what is the right max. Okay, if you will see the equation that we have derived, right, at each index I need to know what is the left max, what is the right max, and if I am not taking additional space, how I will figure it out at order of one operation. Because now I'm proposing a solution which solve this problem in order of n time complexity, but should not use any extra space. ओके, सो हाउ आई कैन फिगर इट आउट कि इस इंडेक्स पे क्या लेफ्ट मैक्सिमम होगा, क्या राइट मैक्सिमम होगा. ठीक है, तो अगर आप सोचो, राइट, सो डू आई, लेट्स से आई एम स्टार्टिंग एट दिस पोजीशन. ओके, हियर इज माय लेफ्ट index, because I will calculate only these index, and here is my right index. Okay, and I am considering so far left max is 4. Okay, I'm considering so far left max is 4, and I'm considering so far right max will be 5, the last index. Okay, okay, now at each index left, okay, I will check what is the, if left max is smaller than the right max. Okay, that means I need to consider left max only. And now what will be the right max? I don't care whether it is 5 or 6 or 7 or anything. If it is greater than the left max, I don't need to bother about the value of this right max. Why I don't need to bother? Because I am taking always minimum of this left max and right max. Okay, so what I will do, the minimum of left max and right max 4 comma 5 will be 4, and I will subtract the height of the wall, which is 2. Okay, so now I got to know, yeah, we can store 2 unit of water here. Okay, now I will increase this left pointer, because this was the minimum one. Again I will check what is the left max. Left max is 4. What is the right max, which is 5. So again I don't need to bother what is the exact value of right max, but I know it is less than it is greater than the left max. So I need to take the minimum of this. Again the minimum is 4, minus height of the wall is 0. So height of the wall is height of the wall is 0, so 4 minus 0 will be 4, so I will store 4 unit watt. Again I will increase the left pointer. So if you will see, right, we were approaching towards the solution, where which what approach we are using is, we are using two pointer approach, and we are comparing the left max and right max. Let's say if we are running this solution, right, and we will found कि right max is minimum है, left max है, so हम right max को इधर से लेफ्ट हैंड साइड चलना स्टार्ट हो जाएंगे और राइट मैक्स को रिड्यूस करना स्टार्ट कर देंगे. ठीक है. एंड ईच इंडेक्स वी विल अपडेट दिस लेफ्ट मैक्स एंड राइट मैक्स. हाउ? If at each index we will update, like if it is less than uh, right max, right, this left max is less than right max, we will update left max each index. Similarly, if we are going towards left, we will update right max each index if it is greater than the current right max. Okay, I will tell you what I am saying is, if you didn't understand the problem is, so what I am saying, guys, I don't need to bother about if what is right max if it is greater than the left max. And what I am saying is, I don't need to bother about left max if it is greater than the right max. Why we don't need to bother? Because we always taking minimum. Okay, and then we will subtract the height of the wall. Now see how we will write the code for this solution. Okay, let's open a lead code. Okay, let's see how we will write the solution for this. Okay, what I'm saying is, I will take one, like what is the height of the array, height dot length minus 1. Okay, I am taking one left pointer which will start at index 1. I am taking one right pointer which is starting from n minus 1. Okay, n minus 1, because I will start calculating trapping water from this index, not the last index. Last minus 1. Okay, last minus 1. Okay, now I will take one variable called left max, which is height of 0. Okay, and right max which is height of n. Okay, this index will be the, we are considering this is the right max, this is the highest wall. Okay, now we will apply two pointer approach, where we will do same exercise until unless left is less than equals to right. Okay, now here what we will do is, we will compare the current value of left max and right max, and on the basis of this I will decide where I need to move. Either I need to move to the left direction or I need to move to the right direction. Okay, left max less than equals to if right max. Okay, now what we will do is, we will take one more variable int total trapped water. Okay, total trapped water is 0. And what was the equation that we have derived is, at each unit I need to know minimum of left max comma right max minus height of the wall. Okay, this is the equation that we have derived. So let's see. Now at this point, if this condition is true, right, I know left max is minimum. Okay, so I will take minimum of left max, like this equation will give me left max. So what I will do, total trap water equals to total trap water plus left max. Okay, left max minus height of the wall. What is the height of the wall is height of the wall is left, at left index. But let's consider this left max is smaller than the height of the wall, so this value will come negative, but we cannot store negative order. So what we will do, we will take math dot max 0 comma 0 comma this value. If this value is greater, we will consider this value. If this value is negative, we will add 0 into the total trap water. Okay. Now after this, what we will do, so since we are moving from left to right, right, so I need to update the left max also if the current index value is greater than the greater than the left max. So what I will do, math dot max left max comma height of left array. Okay, this will update the left max value and I will increase the left index. Similar activity I will do if right max is less than to the left max. What I will do in that case is total trap water will be right max and height of right right and right max. I will update right max and I will move towards left, so I will decrease the right. Okay, and at the end I will return the total trapped water. Okay. Okay, let's see if there any typo, otherwise we will try to run this solution. What is saying is in the code you have missed semicolon. It is acceptable. Let's try to submit this. Okay, so it is working as expected. So guys, what we have done is we solve this problem in order of n square n. The time complexity will be order of n in this case, because we have used two pointer approach and we have not used any extra space, so the space complexity will be order of n. Okay guys, thank you, thanks a lot. See you in next video.